Okay. Hello again, guys. Can you see the screen? Can you see the screen? Give me thumb up if you see everything, students. Please give me short thumb up if you can see everything. Okay. So I explain it again. It's the exercise is about pressure on a throttle. You have here this water pond, yeah, it's filled with water here inside, maybe a river or a tank or something, a big tank, and you have here your throttle valve, yeah, and it's closed. The throttle is fully closed, it should not open, so it's fully closed, and you have here this throttle. And now what will happen? At first we have a pressure, of course, from here, from the air. How high is it? Can someone tell me how high the pressure of the air could be if we are in normal conditions? If we are on Earth, it's about 1 bar. And now we will have a pressure in our water tank. Yeah. For example, we have here this set value, and we will have a pressure here. Okay. Okay. How high will be the pressure? One question from my side. How high will be the pressure here if Z would be, let's say, 10 meters? Okay. Let's say Z has a value of how high can we make it? Let's say how high is the pressure if Z is 2 meters? Can someone give me the answer? If Z is 2 meters, how high is the pressure here in this position? This position. Yeah, 1.2 bar. Yeah, that's right. Perfect. How high is the pressure? Yeah, that's important. Miss Luxemburger got it right. You need the pressure of the height, and you have to add the atmospheric pressure also. That's important. So P for 2 meters is PR plus Z. How high is the pressure for 5 meters. Can someone calculate it? Yes, perfect, Miss Luxemburger. I think you are pretty smart. You know it. Okay, perfect. But that was not the question. We need the forces on the manhole. So I erase it again. So, perfect. So, now we look a little bit closer at the question. Okay. So, first we need again position S. Oh. ZS. We need the area. And the force is okay. Now we need again the point. We come to this later. Okay. So I write it down here. Okay, and now I make a bit more detailed sketch about this. About this throttle system. Okay, we have the force is acting a bit lower, and if we look on from the front on it, yeah, take it like this. We have here, it's fixed here. And it can rotate here. So it can rotate. Yeah. Okay, here we have our S. And here we have our D. Again. Okay. And yeah, second. And if it rotates, yeah, if it rotates in this way, the water will swallow outside. Okay? So okay, let's calculate the E again. Yeah. Okay, and E can be calculated by ES divided by A times ZS. And just so, wo kommt das her? Das ist die Fläche A und das hier war IS. So, also können wir jetzt. Yes, okay, I speak a bit German, you're right, I will go on with English. Now we have calculated the distance E here. That is the difference from point S to point D. Yeah, and maybe one question from my side. If the force acts directly in the middle on S, here it will, if it acts here, what will happen? Can you open the throttle? Maybe one question from my side. If, for the understanding, if we have this throttle, yeah, this round throttle, and we have a pressure on the throttle, and we have a force here on S, will it open the throttle? Maybe if it's fixed here.
No, it will not open.
Yeah.
Because it doesn't have any leverage, the force.
Yeah, and imagine the pressure forces will be really high. If we have air outside here and we have water inside the system, it will never open. But if we have fixed the throttle in the middle position, yeah, it can, and the force acts a little bit lower, it will push up the throttle and it will open. Yeah, it will rotate. And this is what, so we use the pressure, if we use the pressure of the water for the momentum, then you can open the throttle. Otherwise you will never be able to open it. Yeah? For example, if we fix it here on the bottom, here, the pressure will close it. Yeah? But if we, and or on the other side, if we fix it here, the pressure will be too high. It's best way to fix it in the middle, and then we only need this small momentum influence to open it. And the momentum will be calculated now by M is force times E. Yeah? If we have a force here, we have everywhere forces, and if we have here this E, it will be not directly in the middle, it's a Schwerpunkt, we have it a bit lower, and this will act our force. Maybe I paint it again. This is the throttle. It is fixed here. Here is the S, the middle. We will have a force a bit lower, and then we will have A, and then we can calculate the momentum is force times E. Okay. And now maybe keep this in mind. Now I want to come back to the questions. I wanted to ask you about different deep, I make New sketch. And let's paint it again. Case A. Z should be 2 meters. Okay. And now we have the other case. Case B. So, and what can you see from the formula now? What is a good advantage? What can you see from the formula? You see that we can delete this and we get a momentum of so it will be the momentum will be constant. Okay. So I think that's okay. Okay. Do you have any additional questions about this exercise? Okay. We were lucky. Sometimes we are lucky because we could delete this part, but it can also happen that we don't delete it, then we have to insert set and then we get other values. Okay, I think we can close now this exercise and